Alright, so now to change this into two different lines, we're going to use an add node. An add node is a node in which you can add a set of points, but in which you can also define how a polygon has to be connected through all those points. So if you use an add node over here, let's go into this object. You can see over here we can make a point visible. Let's give it a number, as you can see over here. So you can add like more and more points, for example like this. And so you can define all kinds of shapes. Now we're not going to use this to create the points. What we're going to use is we're going to use the existing points that there are, and in combination what you can do with the polygons, we're going to redefine how the polygons are going to be built up. So let's go over here, and I'm going to delete all these points again. I don't need them. Oops. No, I don't need them at all. I'm going to connect on the top of this the result we have over here, and I'm going to delete the geometry but keep the points. Now first of all I have to switch this off. This is what you would get normally seen. So geometry is being deleted but the points are being kept. Now if you see the point numbering, you can see that if we want to have like a straight line going up, we need to connect with each second point. So starting from 0 to 2 to 4, 6, 8 and so on. 1, 3, 5, 7, 9. So we go to polygons over here and we're going to connect them by group. Now by default it's going to connect all the points, just following their point ID. What you can do is also you can make it closed, but that's not something we're going to use. We're gonna change this. We're gonna make the following. We're gonna skip every numbered point. We're gonna skip every second point. And so if we skip every second point, at a sudden we have two straight lines. So 1, 0, we skip this, 2, skip this, 4, skip this, 6, and so on. So now that we have two straight lines, we're gonna optimize the shape a little bit, because I want to be able to stretch this one out. Well, no, I'm gonna do this later. We're gonna optimize this later. What we want to do right now is we want to use the lines that we have over here to extrude or to sweep or to loft, depending what kind of program that you use, a shape over this line. So create a circle, make sure it is a polycircle. Let's make this one visible again. So we make from this a polycircle, perhaps have a little less divisions. Let's set it to 8. Connect this. It's not obligatory, but it's easier, and let's make this smaller, something like that. And now we're going to use a sweep. So tab, sweep, and let's sweep the circle over this line. So again, this is the cross section, middle mouse button. This is the backbone, the line which we're going to use. These are reference points, but that's something you will see later, or you can look up yourself. So over here, as we can see, we have this circle now being copied over all of these points. Let's make it even smaller. I think something like this will be more appropriate. Now the only thing that we need to do is we need to skin it as well. And skinning is either an operation that you can do separate, or you can use over here the built-in operation of it. So skin unclosed, and we get something like this. So again, if we merge the whole thing, and let's bring this all a little bit lower, then we see we have this whole line over there again. Now I can just delete the X-form tree, which are these lines. I don't want to see them over here, so I'm going to delete it over here. So I select the merge node, and you can delete one of the connections, just like that. So, righty. This is all fine, except for one thing, which I still don't like, is that normally seen you make these parts just a little bit longer. They're just very short over here. So we're going to increase their size. Now for that, we're gonna do the following. We have these lines. What I'm going to do is I'm going to create normals which are either pointing towards each other or pointing away from each other. It doesn't matter that much really. And I'm gonna move then later on those points following the normals. So just one thing that I need to fix first is all these points in between. We don't need them anymore. We need to get rid of them. Now what we can do for that is we can use a refine node. And the refine works in two directions. It works as either a system to subdivide a spline or a curve, but you can also use it to clean up a curve. It has two functions inside the refine node. So press tab, refine, and what this refine node does is the following. First of all, you set an influence area using U and V. This is a parametric U and V, so it's not a UV that you can see right in the viewport. So if you press spacebar 5, this is the UP viewport. You don't see any UVs being applied yet. But that doesn't mean that this object doesn't have any parametric UVs. Parametric UVs are just geometrical UVs which are not being used for textures again. So using those UVs, and since that I'm working on only curves, I only have views, I can set a certain range where this operator has to have its influence, as you can see with these lines when I start moving up down. So let me bring this just to the first U, and the second U I'm going to keep it more or less over here so that you can see the difference. So what we're going to do is we're going to unrefine what we have over here. And by unrefining, you see the result immediately. All the points in between are just being removed. So now I can make sure that everything is clean by setting that selection from 0 to 1. Again, like that. Okay, so we have two lines now with 4 points and a set of primitives. Okay, so now we have to make sure that we are going to compare two positions of points. We're going to compare the position of this point with the position of that point, or compare is better to say we're going to subtract these points from each other. Now this is a bit difficult because we have a whole set of primitives over here. We have two primitives. So if I would compare by default, saying I'm going to take the next point, then as you can see it's going to use point 1 over here and then point 2 and so on. So this is not a good idea. We need to be able to change something about it. We need to be able to shift it somewhere, some way or another. Now what you can do is you can use a sort node. So by pressing tab and using sort, you add a node which can be used for all kinds of operations to sort either the primitives, so these are the numbers of the primitives, or the numbers of the points. So what we're going to adjust is the point number. We want to make sure that we have 0, 1 over here and 2, 3 over here, something like that. Now in order to do this, we're going to change by vertex order. And as you see, by vertex order, it is just adjusting everything just the way we like it. We have everything on the right spot right now. So now the only thing I need to do is we need to be able to make a proper shift as well. We need to be able to change the 0 to the 1, and the 1 to the 0, the 2 to the 3, and the 3 to the 2. So in fact we need to be able to flip these shapes around. Now for that we're going to use a reverse node. Now we've seen before that we're using the parametric UVs to define where we're just going to remove all those points. Now these UVs, they have a certain direction. They start from 0, go to 1. As you can see over here, start from 0, go to 1. So what we see right here is a direction which goes from here to here. Now what we're going to do is we're going to, after the sort, we're going to reverse that direction and then do a vertex sort again, or a point sort again based on the vertices, on the vertex connections. So by doing that we're going to change the order. So let's create a reverse node. Oh, that's a revolve node, sorry. Reverse. Let's create a reverse node. And after this reverse node, we're going to use the sort node again. You can just select the node over here and do Ctrl C, Ctrl V to copy paste the node with the same properties. So now we've changed it by vertex order. So if you see both of these, see 1, 0 has become 0, 1. Same over here, 3, 2 has become 2, 3. Okay. So now what we're going to do is we're going to subtract the positions from each one of those. And subtracting gives you a vector direction. So let's add a points up. And the points up, you can see it a little bit as a Swiss Army knife for everything which has to do with points. You can do all kinds of things using variables and expressions. But again, this is something we're going to go in much deeper later. So we have two input ports, source 1, source 2. What I'm going to do is I'm going to connect source 1 over here, and source 2 is like just an extra point of information. As you can see, the shape is still here. I can connect the second one to here, but that doesn't change anything. The second port is just for you to use in combination with the first point number. So you can create all kinds of operations and simple formulas which use or which do things with data from the second point over here. So what I want to do is I want to create a normal, like I said. I want to create normals which are in a proper direction for us to use. So what we're going to do is we're going to add normal. Now if you see the normals over here, it shows you these really strange signs with a dollar sign in front of this. Capital dollars. Dollars, I mean, and capital letters. Now, these are called variables. You need to remember this. Dollar, capital letters. These are variables. They are taking information, point attributes, which are coming directly from the node on which it is connected to. So that's a very big difference with the thing that we did in the expression. Remember the expression that we did right over here, in which we took the line right over here and that we got information from a node which wasn't directly connected. So this is an expression, something like this, to get information. And sorry, over here, these are variables. Now I'm going to remove these variables over here. I don't need them. These are just saying that they're going to read in the normal values and going to place the normal values again. So in fact it's just not doing anything. It's the same with the position. It's taking in the position, so translate x for each point, translate y for each point, translate z for each point, and it's going to write exactly that value again. So if you would do, for example, times 2, as you can see, it multiplies those original values. Just leave it as it is again. Now, for creating a normal, creating something in space, let me show you a side view over here. I do this by pressing space and the number 2, or the number 3 over here, number 3. So as you can see on the grid, we can have all kinds of positions. You can see the values over here. So this is a value of 1 and this is a value of 1.7, something like that for the height. Now if you want to have a normal aiming at this position, what you do is, for example, you take the value that you have over here, so the 1.7, and you subtract this value from that. You subtract 1, so you get 0.7, and 0.7 is a normal which is going up exactly the same height. Do this for the x as well, and do this for the z as well, and you have a vector pointing into exactly that same direction. So what we're going to do, using variables like I just explained, we're going to read in the positions of the very first connection. So $tx, $ty, $tz. Now if you're gonna see what the normals are of these, you can see that they're just aiming away from the center point. That is because you're just showing the positions, or you're just giving in the positions over here. So the position of this point is indeed exactly this vector. Now what you see over here is not an exact representation. This is a representation of the normal which has been reduced in size, because otherwise in most of the cases, if you do them like really proper normal length, you will see it will clutter the visual much more than you would like. Okay, so what we're going to do now is we're going to subtract another position, $tx2, and tx2 is from the second input port. Now as you can see over here, everything is still in red. I guess this is also something from this alpha version, because you shouldn't see that. Normally seen, if you make an expression like that and it is correct, it should turn up green, and it's not doing that. But you see, it is still working. $tz2, and as you can see now, we have normals which are in exactly the right direction that we want them to be. Now there's just one thing. We do have normals over here, but the bigger our object would get, the longer the normals will be. And the longer the normals will be, the more the object will react in a different way, because it's using the length of the normals also to transform, although I'm not 100% sure of that. Let's check that. So what we want to do is we want to transform now these points along their normal. Alright, for that again, look into manipulate, and we're going to look for the following, which is the peak right over here. And peak allows you to move points along their normals. So as you can see, now these points are just moving exactly in the direction that we want them to move. But as you can see, we have a value of 24, of 25, something like that, and this represents a certain offset. Now it might be, I'm not sure, that this will give a different story from the moment on that we start to multiply this by 2. And indeed, as you can see, this suddenly has done double the distance. So again, let's undo this, because that's something we don't want to have. So we need to normalize first the normals, making sure that they are unit length. Okay, for that we're going to add again a facet node. And you can see it right over here. Make the normals unit length. So if you go over here, make them unit length, you see it changes the size over here, and it changes the result that we have over here with the peak. So now to come back to the whole thing, we're gonna change just a few things over here. We made sure that we can now scale the whole thing. So now we're going to use the result we have over here in the sweep node, and this is going to give us two things. First of all, it's going to make sure that all of these points that we're not going to use are being removed. And secondly, it's going to give us longer rails. So let's go over here, connect it, and with it just right here. Right. Now the only thing we still need to do is we need to end the caps over here. There are holes and we need to cap it. For that you need to use the polycap tool. Polycap. And polycap does what it says. It caps the polygons, but it's not capping everything automatically. It needs a group first in order to work, and the reason for that is that you could have an object with all kinds of holes, and perhaps you don't want to use all those holes, you need to use just a few of them, and therefore you have to define a group to just define all the groups that you want to be capped. Now I think it's a little bit strange. I would say that as a default behavior normally seen, it would cap just every hole, but that's not how it works. Okay, so you can add again a group, and we don't have to do anything special right now because the group is automatically selecting all the primitives. As a group name, we're going to change over here the naming. Hang on, change this to ends. And then in the polycap, once we add the ends inside, you see it's grouped just nicely, and we can merge everything as one object. So this created our very basic staircase. Alright, now the next step, what we're going to do in the next part is we're going to remove some of these points because this is quite irritating. I'm going to remove the very first stair as well. And what we're going to do as well is we're going to add the whole thing into a digital asset, because right now we see we have like this whole lot of nodes. That's one thing, and what we're going to do is we're going to make sure that we can create just one node out of that with the controls that we like. So controls, for example, to make these things longer, to make these things higher, so just the controls that we need. Okay, that's it for this part.